Picture this, a calm and ordinary day on Earth. People going about their routines, the hum of everyday life filling the air. But then, something inexplicable happens. The world around you begins to ripple. It's not an earthquake, it's something much stranger. The ground doesn't shake, but distances seem to stretch and compress, as if reality itself is being squeezed and pulled like a rubber band. The effect is subtle, almost imperceptible at first, but then your GPS stops working, clocks across the planet go haywire, and communication systems break down in an instant. What's happening? You've just experienced one of the universe's most mysterious and powerful phenomena, a gravitational wave. But not just any gravitational wave, a massive one, powerful enough to warp space-time on a level we can hardly comprehend. Gravitational waves are ripples in the fabric of the universe, caused by cataclysmic events like black hole mergers or supernova explosions. They travel at the speed of light, distorting everything in their path. Normally, these waves are so faint that only the most sensitive instruments can detect them. But what if one wasn't faint? What if Earth was struck by a gravitational wave so massive, so extreme, that it could reshape our understanding of reality? In today's journey, we'll explore what gravitational waves are, how they're formed, and what it would mean for Earth to be hit by one of unimaginable magnitude. Prepare yourself for a ride through space-time itself, because this story is as vast and mind-bending as the universe it takes place in. To grasp the sheer magnitude of this event, let's start with the basics. What exactly are gravitational waves? To answer that, we need to dive into the very fabric of reality, space-time. Imagine the universe as a vast, flexible sheet, like a giant trampoline. Now, imagine placing a heavy object, like a bowling ball, on that trampoline. The weight of the ball creates a dip, distorting the surface around it. This is a crude analogy for how massive objects like stars and planets bend space-time. But what happens when something truly extraordinary occurs, like two black holes colliding? The collision sends ripples through the trampoline. Ripples that spread outward, carrying energy across the universe. These ripples are gravitational waves. Einstein predicted their existence over a century ago, but it wasn't until 2015 that scientists finally detected them, thanks to an experiment called LIGO. This groundbreaking discovery confirmed that when massive objects collide, they send out waves that stretch and compress space-time itself. But the gravitational waves we've detected so far have been faint, barely detectable by our most advanced technology. What if one wasn't faint? What if Earth was struck by a wave so powerful that it shook the very foundation of reality? To understand the potential impact, we need to explore where such a wave might come from. Gravitational waves are born from the most violent and energetic events in the cosmos. But not all waves are created equal. The size and power of a gravitational wave depend on the magnitude of the event that generates it. Let's start with the most common sources, merging black holes and neutron stars. When two black holes spiral toward each other and collide, the energy released in that moment is unimaginable. The resulting gravitational waves ripple across the universe, carrying the echo of this cosmic dance. Now, imagine something even more extreme. Picture a pair of supermassive black holes, each millions or even billions of times the mass of our Sun, colliding. The gravitational waves from such an event would dwarf anything humanity has ever encountered. But there's more. Theoretical phenomena, like the snapping of a cosmic string, an ancient relic from the Big Bang, could release a burst of energy so intense that its gravitational waves would stretch across galaxies. Or consider a hypernova, the explosive death of a star so massive it collapses into a black hole, releasing a tsunami of gravitational energy. These events are rare, but they're not impossible. And if one were close enough to Earth, the gravitational waves it produced wouldn't just pass us by unnoticed. They would disrupt everything we take for granted about our stable, predictable world. So, what would happen if Earth was hit by a massive gravitational wave? At first, you might not notice anything. Gravitational waves are silent and invisible, passing through matter like a ghost. But their effects on space-time would be anything but subtle. As the wave swept through, it would stretch and compress space-time itself. Imagine holding a rubber band and pulling it back and forth. That's what would happen to the very fabric of reality. For a brief moment, distances would change. The ground beneath you might seem to ripple, though you wouldn't feel it in the same way you'd feel an earthquake. But the real chaos would unfold in our technology. Satellites in orbit, which rely on precise measurements of time and space, could be thrown off course. GPS systems, essential for navigation and communication, would fail. Global networks would falter as timekeeping systems went out of sync. Even stranger, time itself could be distorted. Clocks might tick faster or slower, depending on where they were relative to the wave. This isn't just science fiction, it's a fundamental aspect of how gravitational waves interact with space-time. In extreme cases, the wave could even trigger earthquakes as it stressed the Earth's crust or disturbed the planet's gravitational balance, leading to long-term effects on our orbit and climate. The impact would depend on the size and intensity of the wave, but one thing is certain. Life as we know it would be profoundly affected. Here's the big question. Could humanity survive a massive gravitational wave event? The answer depends on the wave's intensity and our level of preparedness. The good news is that Earth has weathered billions of years of cosmic activity, including countless gravitational waves. Most are too faint to affect us in any noticeable way. But a truly massive wave, one from a nearby black hole collision or a cosmic string event, could push the limits of our resilience. The key to survival lies in understanding. By studying gravitational waves, we're not just unraveling the mysteries of the universe, we're also preparing for the unexpected. Could we develop systems to mitigate the effects of space-time distortions? Could we predict these waves with enough time to brace for their impact? These are questions science may one day answer. What's certain is that humanity has always risen to the challenge of understanding the cosmos. From detecting the faintest ripples of space-time to exploring the edges of our solar system, we've proven time and again that curiosity and innovation are our greatest tools. Gravitational waves are a testament to the power and beauty of the universe. They connect us to the most violent and energetic events in existence, reminding us of the vast forces that shape our reality. If a massive gravitational wave ever hit Earth, it would be a moment of profound significance, not just for science, but for all of humanity. It would challenge us to rethink our place in the cosmos and inspire us to push the boundaries of what we know. So, as we continue to study these incredible phenomena, let's remember that the universe is full of surprises. It's up to us to be ready for them, to learn from them, and to keep looking up with wonder and curiosity in our hearts. Thank you for joining us on this journey through space-time. Don't forget to like, subscribe, and share your thoughts in the comments below.